take a look at this equation. What do you think the solution is? Yeah, 3 works. When we substitute 3 for the variable, we get a true statement. But you know, that's not the only solution to this equation. Can you think of another one? Right, -3. -3 squared is also 9. We could also write that as our solutions are x equals plus or minus 3. Now we got those solutions by just reasoning them out. But there's another way to do it, and this is by using something called the square root property. Notice that the left side of this equation says x squared, and we'd really like it to say x. So we'd like to undo the square that's on the x. We'll do that with the inverse of squaring, which is a square root. If we take the square root of both sides of the equation, we still have a balanced equation. But we do know that we should get 2 answers from this equation, not just 1. So to recognize that, we'll say that the square root of x squared is plus or minus the square root of 9. The square root of x squared is x, and the square root of 9 is 3, so that leads us to the same 2 solutions. X equals plus or minus 3. Now let's look at another equation. We'll use the square root property to undo the square that we see on the left side of this equation. When we do that, we can see that x minus 4 is equal to plus or minus 5. Now we're not quite done because we want to know what x is, not what x minus 4 is. So we'll have to do one more step, and that's add 4 to both sides of the equation. Before we do that, let's rewrite this as the 2 equations that it represents. X minus 4 equals positive 5, or x minus 4 equals negative 5. Now we'll solve for x by adding 4 to both sides of the equation. Both sides of both equations, that is, to get 2 solutions, x equals 9 or x equals negative 1. Let's see what happens if we try to solve this equation. We know that we can use the square root property to take the square root of both sides of the equation, and that undoes the square on the left side. But now what we notice on the right side is that we have an irrational number, the square root of 5. That just means we'll have 2 irrational solutions. We can still rewrite this as the 2 equations that it represents. Either x minus 4 equals a positive square root of 5, or x minus 4 equals a negative square root of 5. And now if we add 4 to both sides of both equations, we get our 2 irrational solutions. X equals 4 plus the square root of 5, or x equals 4 minus the square root of 5. Now here's something you need to know about the square root property. We can't always use it to solve a quadratic equation. Okay, you look a little worried. Let me clarify that. We can't always use it immediately to solve a quadratic equation, but we can always use it. What we'll need to look for is whether or not the side of the equation with the variable is a perfect square. If it is, we're ready to go. We can take the square root of both sides of the equation. So let's look at an example where we're not ready to use the square root property immediately. The left side of this equation has a perfect square in it, but it also has a minus 7 term. If we add 7 to both sides of the equation, we will have a perfect square on the left side of the equation. And then we can go ahead and take the square root of both sides of the equation, and then rewrite that as the 2 equations it represents, and solve just like the last problem we did. And here's one last example of a problem in which we can't use the square root property immediately, but we can if we rewrite the side of the equation with the variable so that it's a perfect square. In this case, what we'll be doing is completing the square on the left side of the equation. So first, let's subtract 3 from both sides of the equation. And then to complete the square, we know that we'll need to add 9 to the left side. We'll do that to both sides so that we have a balanced equation. But now the left side of the equation is a perfect square. And now that we've got that perfect square on the side with the variable, We can take the square root of both sides of the equation and solve for the x to get our two irrational solutions to this quadratic equation. So did you notice what the key to using the square root property is? Yep, it's making sure that the side of the equation with the variable is a perfect square. If it isn't, then rewrite the equation. And then once it's a perfect square on the side of the equation with a variable, take the square root of both sides of the equation and go ahead and solve.